Good morning, ladies and gentlemen. So thanks for joining this session. Today, we will talk about how to build your serverless container cloud with OpenStack and Kubernetes. So as we know, Kubernetes make container easy to deploy, manage, and scale. So however, using Kubernetes on OpenStack or other infrastructure as a service still require user to manage the underlying infrastructure, also such as the cluster of virtual machine. For user, they are responsible for the initial capacity planning, as well as the maintenance of the cluster. So the emergency serverless container technologies, such as the Azure Container Instance, as we know the ACI, or AWS Fargate, the Hyper, and our OpenStack project, Zun, they will offer another approach for run container in the cloud. This serverless approach, we can just treat it as a clusterless. They will allow users to run container without caring about the underlying infrastructures. And also, they don't need to pre-create or provision the virtual machine. Today, we will talk about how to make Kubernetes zero server management by the serverless container cloud solution. So now let's begin. I have to introduce myself first, sorry. I'm Kevin Zhao from ARM. I'm China. So I am the OpenStack Zun project code reviewer. Here is the agenda for this talk. There is almost 5 parts. So I will elaborate the serverless container cloud first. Besides, I will talk about the Zun and container capsule, and then how to build the serverless cloud. And in the last part, we will have a small demo for this. So the question, what is the serverless container cloud? For a better understanding of the container cloud, we could treat it, what is the traditional container cloud now in our cloud solutions? So so for running cloud, user need to provision or create the clusters first in the cloud infrastructure for OpenStack or other service. So on top of this, there are several container orchestration engines, the Kubernetes, the Swarm, or Mesos. After build all the solutions for user, they could create containers or or deploy their applications. So even though for user, they are a multi-tenant isolation in the cluster level, so they will induce the problem about the low resource utilization. Also, it couldn't offer support about container level multi-tenant support. So for tenant, the cluster is isolated, but not for containers. So what is the serverless container cloud solution? So that means the clusterless widget. So for users, they just need to focus on their applications. They don't want to care anything about the underlying infrastructure. This serverless approach will reduce the gap of running container in the cloud. Since they can offer the API for create and manage the container, you can just run container with one command in cloud. Also, they will offer the container level multi-tenant. So in Zun, we will leverage the keystone support for containers. And as we know, the Kata container has released. So for using these virtualization container solutions, such as the Kata or the Hyper-V, they can offer a hypervisor level container isolations. So users don't need to care about the container security problem. We could have a conversation about that. So for any user, they can just build cluster, enable the cluster network, finish all the building work about the clusters, and then run containers. But in the red picture, we could say run container in the cloud is very easy. So you could treat it just one command, and it will be created, and all things you don't need to do. We could see it is a cool technology about the serverless container technology. But as we know, Kubernetes is the king of COE, and the users are suitable or they are familiar with using Kubernetes. So how to connect it with them to make them work together? We will leverage a project in the middle part of the picture. We call it virtual Kubelet. This is a project for making the container service as a virtual Kubelet node. So we could see in the picture, there is a Kubernetes cluster, and there have two Kubelet nodes. So we could treat the Kubelet node just the same as OpenStack compute node. They are running the containers. So the pod is a Kubernetes key unit. It is a basic unit has been scheduled. So application users or the infrastructure users, they could deploy the task with the Kubernetes control plane to the Kubelet node. Also, thanks to the relying of the virtual Kubelet project, they could deploy the pod information. They could deploy the pod to the OpenStack Container Service Zone or other container services, such as the ACI, the Fargate. So we could see in this level, the whole Kubernetes cluster, OpenStack cluster has been treated as a Kubelet node. So we treat it as a OpenStack as a virtual Kubelet node. So for user, they could use the Kubernetes on top. And the backend realization is about Zone. The OpenStack will be the backend driver for running containers. User can deploy their common workloads by the Kube control, just as they used to do. And for users, there's nothing different. They just need to do is specify the workloads to this virtual Kubelet node, and then run the workloads all the same. As we say, how to build this serverless container cloud with OpenStack and Kubernetes. So there are two, what do we need to do initially? Yeah, as we know, initially is build a cluster. So here I elaborate two integration methods about the cluster. We need an OpenStack cluster and a Kubernetes cluster. We could use a standalone OpenStack and Kubernetes, but please make sure that the network between them are connected. That is enough. And also, OpenStack has several deployment tools for running the COE. We could use Magnum to provision a cluster, and also running the Zone service in OpenStack. So that will guarantee the network connected, and we could use them. So we could say for OpenStack, we need container service Zone, and for integrating with the Kubernetes, we need a project called Virtual Kubelet Support. So in the next two sections, I will talk about the detailed information. So the first is about the Zone project. It is an OpenStack container service. So in the red picture is about the real Zone. You may be very confused about it is a very strange word, right? It is not an English word because it is a Chinese word, and it means that the one container from Asian China. So we treat it as a project logo. And also, since the OpenStack lists its project with the sort of alpha beta, so you will be very easy to find this project because it is always the first one from last. Continue. We could say, what is Zone? Zone has a mascot of the dolphin. So it is a container service of OpenStack, and it will provide the ability for provision and managing the containers. For users, they don't need to care about the underlying infrastructure. It will treat the containers as the first level resources, just the same with virtual machine. The container will have the network support, will have an individual IP address, just the same with VMs. And user, could arbitrate the virtual CPU, the memory, and other resources such as the PCI pass-through or other attribute to these containers. The goal for doing is make user focus on their application. Especially for the developers, you don't need to learn much work about the COE. Yeah, just one command to make it work. So we could say that Zun is an open source ACI or open source Fargate project. And also, since user just launch the containers, so it will be just a page what they need. So for user, you maybe run clusters and run your containers. You need to pay the virtual machine. You need to pay the whole cluster money. But in the Zun cluster, you just launch the container, so you need to pay is the container's money. Zun will support the container drivers such as the Kata, the Docker, and other projects and other container runtime. Here is what is Zun related with OpenStack. So Zun is based on the OpenStack clusters. It has a it could launch as the virtualization and also the bare metal. So each tenant we treated now as a project will have its own containers unit. And also we could say there is a capsule I will introduce later. It is also a basic unit just as a Kubernetes pod. So each tenant will have a container isolation, container level isolations. Here is a relationship between the Zun project with OpenStack other services. So for container inside OpenStack, the Zun will provision and manage containers with the API support, and the Keystone will offer the multi-tenant authentication tools for the service discovery or other things. The Glance will serve as a central image repository just for the virtual machine and for container. A Cinder will be treated as a block device support. And also, by relying the Kubernetes network, the container could connect it with the OpenStack neutral network. So each container will have an individual IP address. It will connect it to your existing virtual machine very easily. So we could say, by integrating with these modules, Zun will offer quick spawning of containers. And doing so, make OpenStack networking, the storage, and the authentication tools are available for the container fleets. It will offer the such of containers need for the user to carry about the compliance and securities. So especially for users that are used with OpenStack and you have familiar with the OpenStack APIs, so using Zun is very easily. We will say there is a screenshot about how to use Zun. It is very easy. So we have defined the Zun command just the same with the Docker or other container command lines. We should use one command we could use one command to create the container, and we get a log or exist or other operations are supported. But we see there is only one command. As we know, many users are familiar with the Kubernetes, and much of the container using scenario may be the multi-container composition work. So they're coming to a problem about how to implement pod in Zun, because we say that we will make the Zun as a backend provider for Kubernetes, for the Kube control. So we have defined a new concept that's called capsule. So capsule, so we treat the minions as a capsule mascot. It is just the same. So for one capsule, it is a basic unit also in Zun project. It will have one sandbox container and several function containers and several volumes. So this capsule will be the basic unit in Zun. And also, when scheduling, one capsule will share the same resource limits, and they are co-scheduled and co-located to one Zun node, to one compute node. Also, since the whole capsule is a beta unit, the containers will join the network namespace, the IPC PID to the sandbox container. So they will share the same IP address and share the same network namespace. They will offer the support to the outside with the same IP. And each capsules each containers inside this capsule, they could ping each other with the local host. And you could specify the different port to make their communication. So it looks like just the same with the Open Kubernetes pod. Next, we will see, so what is the capsule interactive with the OpenStack service? And OpenStack exists virtual machine and bare metal. So Neutron and Cure will enable network, and the Glance, Cinder, Keystone will offer their image repository, the Cinder, the block device support, as well as Keystone will offer the authentications. So for users, they could use a unified OpenStack API to create their container and capsule just the same. Here, we have defined the capsule template. So for user, you could just use this template to create a capsule. So for integrating with the Kubernetes pod, we have defined the template Kubernetes friendly. So if you're familiar with the Kubernetes, it's just very easy to create a capsule inside Zun. It's very easy with just one command. Here we have defined 4 capsule API. Just the capsule create, list, describe, and delete. The 4 API will offer support for users. After that, I have a small demo for the capsule, about 2 minutes, we could see. There is a capsule template. And now we could say, no, there don't have any capsules in the Zun service. And we could use the Zun capsule create to create this demo. We will say the containers inside the capsule has been created. And after a while, the container will launch. We could use the capsule list to see the status. We see that it is running. We will check here we have created an Nginx container and a MySQL and a CentOS. So we could check the Nginx work with the IP with the IP shore, and the port is 80. And also we could check that the capsule, the MySQL container, whether it worked. We will specify the MySQL configurations and set the capsule IP address to the same IP, 172.24.4.8. So we say that the MySQL container is also work, and also the MySQL and the Nginx container, they are share the same IP address. Also, when creating, we have set a container. We have set a container MySQL database called Nginx, and we see it has been created. And in the last procedure, we will use a command to delete this capsule. We see the capsule is deleted, and we could use the capsule list to see the status. Sorry? There's a missing. I'm missing this capsule list demo, sorry. I'll continue. So after the whole introduction about Zun project and the capsule, we will continue to see how to integrate this with make this support in Kubernetes. We will leveraging the project before just called the virtual kubelet. This virtual kubelet is a kubelet implementation. it will masquerade the container services as a Kubelet node. So for user, the best practice is Kubernetes on top and program the back. So you could program what you want in the container service and to make it as a Kubelet node. It will be the intermediary to make the Kubernetes request and the resources to the container service. So for user, they use a Kube control, and the container service will serve as a backend service. So moving on, we will see a scheming diagram for this virtual kubelet. So here is a diagram for the virtual kubelet. The font is a little small, sorry. So we see there is a typically Kubernetes cluster for several nodes. So the first 4 nodes, they are the typical node, a typical Kubelet node. Maybe they are running in the virtual machine or in the bare metal. Anyway, so user could implement the pod and container in it with the Kubernetes API. And the last one, we see the virtual Kubelet node. So virtual Kubelet node will register itself as a node in Kubernetes, and that will allow the developers to deploy the pods and containers with their own API. Also, you could use the Kubernetes API, all the same. So in order to become the virtual Kubelet node, the container service need to implement several functions. About the pod functions and the node functions, we have seen just part of them are listed here. So in the next several slides, I will talk about the details about the virtual Kubelet work, and also what we have done to make this happen. So here is modules about virtual kubelet. There may be 3 main modules in virtual kubelet project. So in the central is a virtual kubelet main process. It is a key modules, and it will talk with the Kubernetes cluster and also talk with the resource manager and the provider. The resource manager is an info cache. It will record the pod information and node informations, just the pod informations in the resource manager. Besides the provider is a backend driver for the container service, for the virtual kubelet. It will connect it with the container service for ACI, the Fargate, the Hyper, and Zun. So if we choose Zun, we will use the Gopher Cloud with it to communicate with the provider. And virtual kubelet will use the Kubernetes client to the Kubernetes cluster. We have, say, the detailed information to make it clearly. So I will introduce the right part first and then the left part, because it is a little complicated. So first, it's about how to interact with the Kubernetes cluster and the resource manager. So the virtual kubelet main process just do 2 important things. So one is a register node. It will call the provider functions called capacity. This capacity function will offer the provider information such as the memory, the disk, and the CPUs, also the operation system or other software info to tell to the virtual kubelet. And after it gets the virtual node information, it will fill into the Kubernetes node object. And then we will say it will call a functions to create a node. It is very simple. So just here in the 2. So besides, another important function is about sync pod and node here. There are 2 methods to sync pod and node. One is a watch pod request from Kubernetes. So virtual kubelet will create a pod watcher to see the difference, to see and to check the pod request from Kubernetes. And then when checking the information, it will update the information to the resource manager. Besides, it will create a periodic task to update the node and pod status from the provider to the Kubernetes. So we could see the arrow from the virtual kubelet main process to Kubernetes. So virtual kubelet main process will be the proactive one. He just he just create the read and the write actions from itself to Kubernetes. And also for resource manager, we could say there are two roles, because that both the information from the Kubernetes cluster and the information from the provider, so they will be write into the resource manager. After that, we will see the interaction and interaction with the provider and the resource manager. So as we know, if a Kubernetes API KubeControl user has created a pod in their has created a pod request, it will create a pod, and the information will be added in the resource manager. So the virtual kubelet has used the reconcile function to talk with the provider. There is a create function. We could say how to trigger the pod create in provider. So we could get first, it will get pod from the resource manager. As we see, there has been a new pod request there, and also it will get the pod from provider. Then they will have comparisons between them. So if the pod didn't have the deletion time swap, we know that if the pod has the deletion time swap, it means that it has been deleted before. So then that will be trigger the pod create process. And for delete, when the Kubernetes delete pod, the information will be updated to the resource manager. So when we get a pod from provider and check into the resource manager, we will see that this pod didn't exist in resource manager. So it will call trigger the delete pod operations in provider. So for implementing the provider, we see that there needs a pod function operations and node operations. So for pod, there are several pod create and delete or other options. And node is mainly about how to get the node information about this. So in the future, we will also add several support for the config map and secrets from Kubernetes. So we could say what we have done to make the Zun support in the virtual kubelet and make this connected happen. So just from two parts. So first is about communication. That will be, we should add the Gopher Cloud support for Zun, because Zun is a totally OpenStack Python-based code. And the virtual kubelet and Kubernetes, they are written by Go. So how to communicate it with them? So you need a Gopher Cloud support. This Gopher Cloud is an OpenStack Golang client. After that, we have a virtual kubelet Zun client support in the virtual kubelet to talk with the Gopher Cloud. So besides the communication part, we have do something in the resource providing. So just the capsule we have defined. Although we have defined the capsules just the same as pod, but we have make sure that we have pay attention that capsule is in OpenStack and the pod is in Kubernetes. So we have remit the functions and we have do the realizations from the capsule. Several of the configurations between the pod and capsule are different, so we need to remap them. Also, we have implemented the provider essential functions. We have referred about the pod operation and the node operations. Okay, in the last part, we will say how to create a pod from Kubernetes to the OpenStack Zun provider. It is very easy. So first, when KubeControl, the user uses KubeControl to create a pod first. And then there is a virtual kubelet pod watcher. It will watch the pod request. And the resource manager will catch the info in it. It will add the pod to resource manager. After that, the virtual kubelet reconcile function will get the pod from Zun and compare with the resource manager. After that, the provider will create a pod and remit the attribute from pod to capsule. Moving on, the provider will call the Gopher Cloud capsule create. And the last procedure is about the capsule create in Zun. So that is a workflow from the KubeControl to Zun provider. So in the future, what we should do? We need to do several other functions. First, enhance the virtual kubelet support for config, map, and secret. So besides, we need to enhance the capsule implementation and operations. We see that we are lacking a capsule upgrade. So besides, we will have a line with the Kubernetes-related attribute from capsule to pod. And for Zun, we also need to implement the cinder multi-attach for container. In the last part, I have a demo for register. The font is a little small. We could see, using Kubernetes, there is only one node, called it is a master node. And there is no capsules in Zun. Then we will use a virtual kubelet deployment. We will create a node in this provider. We will run the virtual kubelet we see. After that, we use a kubecontroller to create a node, to create a deployment about a VK deployment. And after a while, we will see that there is a new node in Kubernetes. We see there's a new node in Kubernetes that's called virtual kubelet. We see there is a pod running called virtual kubelet. And then we will have to run several pods and a deployment in this virtual kubelet node. We have defined the engines YAML, and then run these engines. We see the engines is creating. After a while, this engines pod is created, and it is in the node of virtual kubelet. And also, the Zun will offer the IP address. We see there is a IP address is different with the common Kubernetes IP address, right? It is from the Openstack side. And then we will try to connect it with this pod, and we see the engines work well. Moving on, we could delete it. And we see there is no pod now. There is no capsules in Zun now. So when recording this video, I just missed the function about how to show the capsule list when creating. So I just recur to see when we create this node, and we see that there is a capsules creating in Zun. And we see there is the capsule including two pods. So one is a Kubernetes post. It is a sandbox image. And the other one is engines. And then we delete it, and it disappears. So after that, I have a demo to show how to use Kubernetes to create a deployment. We will have to parallel create 8 Kubernetes pod engines. We see that in the YAML file, the RC is 8. So we will create this, and we see there are 8 pods has been created, and 5 pods has been scheduling to this virtual kubelet node. And using Zun, we will see almost all of them now are creating. And we see that much of the node has been created. And we will try to connect it with one. We see this has been created. And in the last procedure is delete them. So use one command in Kubernetes, we could delete this engine's deployment, and all of the 8 pods will be deleted. Then we will check the capsule with the Zun to see whether it has been deleted now. after a while. We could say several pods are terminating. And now all the pods has been deleted from Zune project, from the Zune capsule. And we see the Zune capsule list, there is no pod here. Okay, so here is a demo for register this Kubernetes OpenStack cluster as a Kubernetes node. So moving on, you know that we really need and welcome you to join this project called Zune. It's OpenStack container service. And if you have some questions, you could ping in the IRC. Besides, we already have another two projects to introduce about this. One is about integrating the OpenStack Zune with Kata tomorrow, and we have our Zune project update in the Thursday afternoon. So welcome, Joy. Thank you. Any questions?
Yeah, sure.
Yes.
Excellent presentation, and definitely a way to go with Zune. The one point I could not understand are, what's the relation between Gopher Cloud? What is it? And with respect to the capsule, that is the capsule, you mentioned it as what you call a sandbox. And what is this Gopher? How are they related?
So Gopher Cloud is a Golang client support for OpenStack. So you could use a Gopher Cloud to you could use the Gopher Cloud to create the capsules in Zune. And we use the virtual kubelet to call Gopher Cloud because that this virtual kubelet is written by Go.
Okay.
Yeah.
And does that mean that this capsule which you are saying is sandbox?
Yes, right.
Can it be used for production?
I think it's okay. We have released the one version.
Okay, so it can be used in future as a production, right? Sandbox, when you say it is for testing, correct? Or is it for usable, the capsule, is it usable for production? In production, can we use it?
You mean could capsule be used as a production use, right?
Yes.
I think maybe you could wait until the Rocky release.
Release.
Yeah, Rocky release.
So we will see that in future.
Yeah, we have merged the capsule functions to the master branch, and it will be released in the Rocky release.
Okay.
But now you could try it.
Okay.
Yeah, it's okay.
Thanks. Thank you.
Thank you.
Great job.
Hi.
Hello.
Yeah, I have a question. So let's say I have a Kubernetes cluster with one node as a physical node, okay?
Yeah.
And let's say I have a pod running there with some address and something. And then I use Fargate as the provider and launch a container in Amazon cloud.
Yeah.
Those two pods can natively talk to each other? Yeah, you're saying the pods can communicate directly with the private address?
You mean?
There's one container running in the physical machine, let's say locally, and one container I launch using Fargate as a provider using the Zune, right? Not Zune, actually, Fargate.
Oh, you mean use one virtual kubelet to connect it with Zune or also connect it with Fargate?
Correct. So it's a single Kubernetes cluster, right? So can those pods talk to each other?
Yeah, I think maybe virtual kubelet need this support. So I'm not sure it can connect it parallelly. So parallel to two provider.
Okay.
Yeah.
No, not two provider, right? It's just Fargate, that's it. Fargate and local, that's it. There's no.
So you mean Fargate with the Kubernetes?
Yeah.
So the Fargate has been supported in this virtual kubelet. You could run this. It's okay.
That means the pods can talk to each other. A pod running, let's say, in a physical node, and a pod running in AWS, they are in the same network?
Yes. If your Fargate container has a public IP,
right,
it works fine.
Okay.
Yeah.
But inside the container Fargate, though, it's a private IP, right?
Sorry?
From inside the container, it's always a private IP, right?
Inside the container.
In the Fargate, you will have a private IP, right? Anyway.
Sorry, I'm not very familiar with this Fargate.
Oh, okay. Okay, that's fine. Thanks.
Thank you.